Welcome you all. Today's task is to solve the November 2024 ICT Theory paper. Take note, all the solutions are detailed regardless of the high or low mark allocated, in order to provide clarity on all the tested aspects. Question 1a. Reasons why analog data has to be converted to digital data. Analog data is converted to digital data for several practical reasons. Digital data is easier to store, transmit, and manipulate without quality loss, while analog signals can degrade over time and are more vulnerable to noise and distortion. Digital data is also more compatible with modern technologies, such as computers and digital devices, making it easier to integrate and process using advanced algorithms and tools. Question 1b. Reasons why digital data has to be converted to analog data. Digital data is often converted to analog signals for transmission over analog communication systems like radio waves, phone lines, and TV broadcasting, which are designed to handle analog signals. Many legacy devices and infrastructure also operate with analog signals, necessitating this conversion for compatibility. Analog signals are also more suited for long-distance transmission in some cases, as they are less prone to degradation compared to digital signals. Question 2a. Software that the user used to perform a specific task is called. Software used by a user to perform specific tasks is called application software. It is designed to help with activities such as writing documents, analyzing data, or creating designs. Examples of application software include word processors, spreadsheets, and media editing tools. Question 2b. Software that the computer needs to operate is called. System software is essential for a computer to function properly. It includes the operating system, like Windows, Mac OS, or Linux, which manages hardware and software resources. Additionally, it contains device drivers and utilities that ensure hardware components can communicate with the system. Question 2c. Collective name for physical components of a computer. The physical components of a computer are collectively known as hardware. This includes all the tangible parts that make up the system, such as the central processing unit, CPU, motherboard, memory, RAM, and storage devices like hard drives or SSDs. Question 2d. The component used to process instructions in a computer is called. The central processing unit, CPU, is the primary component in a computer responsible for processing instructions. It handles the interpretation and execution of commands from both hardware and software. Often called the brain of the computer, the CPU performs calculations, makes decisions, and controls the flow of data within the system. It is crucial for the overall operation and performance of a computer. Question 3a. Describe the difference between backing storage and internal memory. Backing storage refers to secondary storage devices like hard drives, SSDs, and optical disks, used for long-term data storage. It is non-volatile, meaning data is retained when the power is off and typically offers larger capacity but slower read-write speeds compared to internal memory. Internal memory, or primary memory, temporarily stores data and instructions for active processes in a computer. Examples include RAM, which holds data in use and is cleared when powered off, cache memory, high-speed storage near the CPU for free. Question 3b. Continuation. Examples of backing storage besides cloud storage. Examples of backing storage besides cloud storage include hard disk drives, HDDs, and solid-state drives, SSDs, commonly used in computers for large-scale, long-term data storage. Portable options like USB flash drives and memory cards are handy for transferring and storing data on the go. Optical discs, such as DVDs and Blu-ray discs, provide a durable medium for multimedia storage, while magnetic tape is favored in enterprise settings for cost-effective archival purposes. Question 3c. Evaluate cloud storage. Cloud storage offers flexible, cost-effective solutions for storing and accessing data remotely. It provides easy scalability, automatic backups, and strong collaboration features, with many services offering free tiers. However, it requires a reliable internet connection and raises concerns about data security, privacy, and ongoing costs. While providers like Google Drive, Dropbox, OneDrive, and iCloud integrate well with various platforms, users must consider their specific needs regarding security and storage volume, especially for sensitive or critical data. A graphical user interface, GUI, is user-friendly and intuitive, making it easier for most people, especially beginners, to interact with software. It offers a visual approach through icons, buttons, and menus, making tasks faster and more accessible. GUIs also allow multitasking by enabling users to switch between applications easily and include safeguards to prevent errors, such as confirmation dialogues or undo buttons. They can be adapted to assistive technologies, improving accessibility for users with disabilities. However, GUIs are often resource-intensive, requiring more memory and processing power than command-line interfaces, CLI, which can make them less suitable for older or limited systems. They can also be slower for advanced users who prefer the efficiency of CLI commands. While offering ease of use, GUIs may limit customization options for more specialized tasks and may hide advanced features, which could frustrate power users seeking full control. Question 4b. Describe the inputs and outputs involved in the use of an expert system. An expert system processes inputs such as user queries or problems, along with relevant data related to the issue at hand. These inputs are then analyzed using a knowledge base that contains facts, rules, and procedures specific to the domain. The inference engine applies logical reasoning to process this information and generate potential solutions or answers. The outputs of an expert system include a solution or recommendation, such as a diagnosis or decision, based on the data and rules it has processed. Additionally, the system may provide an explanation of its reasoning and justification for the decision, helping users understand how it arrived at its conclusion. In some cases, the output may also include diagnostic results, reports, or feedback to support further decision-making. Question 5. Contrast a laptop computer with a desktop computer. Laptops are portable and compact, making them ideal for on-the-go use. They combine the screen, keyboard, and internal components into one unit, allowing for mobility and convenience. However, they typically offer less performance and upgradability compared to desktops, as their compact size limits cooling and hardware options. Laptops are generally more expensive for the same performance and have limited battery life, with storage and power capacity also being less than desktops. Desktops, on the other hand, are stationary and offer better performance, especially for tasks requiring high processing power. They are highly customizable and upgradable, allowing users to replace or add components like the CPU, GPU, and IM. Desktops are typically more cost-effective for the same performance, offer better cooling, and are more ergonomically flexible, though they require more space and constant power. They are the better choice for users who prioritize power, customization, and a fixed workspace. Question 6. State direct data entry devices. Direct data entry devices include tools like barcode scanners, which read barcodes to input data into a system, magnetic stripe readers and smart card readers, used to extract data from cards with magnetic stripes or embedded chips, and optical devices such as optical mark readers, OMR, for processing marked forms, and optical character recognition, OCR, systems for converting printed text into digital data. Other examples include voice input devices, like microphones for speech recognition, and digital pens or tablets, which digitize handwriting or drawings for seamless integration into computer systems. These devices streamline data entry processes in industries such as retail, banking, and education. Question 7a. Identify functions of a router. A router is a networking device that connects different networks, directing data packets to their destinations using routing tables and protocols. It manages traffic, prevents congestion, and enables inter-network communication while translating private IP addresses to public ones through network address translation, NAT. Routers enhance security with basic firewalls, support VPNs for secure remote access, and prioritize traffic using quality of service, QoS. They may also function as wireless access points and handle DHCP to assign IP addresses dynamically, ensuring efficient network operations. Question 7b. Explain how a router routes data packets to a destination. A router routes data packets by examining the destination IP address in the packet and consulting its routing table to determine the best path. The routing table contains entries specifying destination networks, next hop addresses, and interfaces. The router matches the destination IP with the most specific prefix in the table, longest prefix match, updates the packet's layer 2 header with the next hop's MAC address, and forwards it through the appropriate interface. If no specific route is found, it uses a default route or discards the packet, possibly sending an ICMP error message. This process repeats at each router until the packet reaches its destination. The remaining questions from question 8 to question 13 I will explain in the next video. Thank you all for watching and listening.